It turns out life isn't just about booze and parties. Today, we're taking an important step towards more science, titanium. Welcome back to Laurence Plays Factorio Planetary Pioneers for some more Pelagogian investigations. This production all happens on Mike's titanium island. We took an early look at this a while back, but since then he's come in and finished it off, making it more reliable and more productive. As I understand it, the big challenge in this area is balance. The titanium production uses a lot of nutrients and produces a lot of spoilage. Spoilage can be converted into nutrients, but making sure you don't get a surplus or a shortage of either is key. And the system has to be able to compensate for changes in flow rate caused by input shortages or by the output filling up. Also, the fish must never stop flowing. Let's follow it through. Up at the top here, there's 3 copies of the titanium production system, with each block initially breeding fish. We talked about this in the last episode when we covered the ethanol, but I'll admit that's a little out of sequence because Mike actually built this one first. Here, the nutrients are fed in along the middle belt, with the fish being unloaded onto the right-hand one and immediately picked up if needed. If they're not needed to make more fish, they flow down and around and back up the other side to feed the bacteria cultivators. Like in the ethanol area, these should be 1-to-1 as the breeding process produces half an additional fish per second and the bacteria cultivation uses half a fish per second as well. However, this system seems to be seriously limited by the nutrient input, so we're not ending up with the excess fish I'd expect, and that's going to limit us later. The key here is in the order of the arms. The exserter taking the fish out of the machine is before the inserter loading them in, meaning that the system always first reloads the fish into the breeder and only passes the excess on to the rest of the chain. This is repeated for the bacteria cultivation as well, ensuring that even if production slows, the basic breeding stock will be maintained, unless it slows so much that everything spoils. The extra bacteria pour out on the left side of the biochamber to go round another loop to the titanium dust production, and this is where we see the input of titanium sludge. It's a rather stingy recipe. Every run costs us 50 sludge, but there's only a 25% chance of getting any of the valuable titanium dust out, so we'll have to run it a lot of times to get a useful amount of output. It does produce guaranteed spoilage though, and this is what caused the clog last time. Since then though, Mike has been busy with his plunger and has fixed the blockage, so let's check that out. The spoilage flows down into the next level of production, and there are a lot of belts coming together here. Each of the loops above has a filter splitter to pull out anything that goes off. They're all merged together and then combined with some more spoilage that's coming up from below, and we'll find out where that's coming from later. These are then fed past 12 biochambers, all running the spoilage to nutrient recipe, hungrily munching through the spoilage. If any of it doesn't get picked up on the way past, it gets dumped into heating towers at the bottom for disposal. Heating towers never stop burning stuff, even when they get up to temperature, and that's why I circuit control the power one on home island, so they're great as a bottomless sink, at least for flammable resources, and can hide a multitude of badly balanced recipes and a few other sins besides, but Mike says I'm not allowed to talk about those. He also says that this is a bit of a mess, it needs refactorioing to make it easier to monitor and modify if necessary. Nutrients from spoilage is another quite expensive recipe. It takes 10 spoilage to make 1 nutrient, which explains why there's not a huge amount of it coming out. Since the nutrients can turn back into spoilage when they go off, it's a good thing it's a less than 100% return rate, or we'd very quickly get overwhelmed with loaves and fish, and that's not the miracle we're looking for. All that nutrient gets thrown on an output belt and then up to feed the titanium systems. That output is then evenly split 4 ways, with this splitter first and then these 2, and this means that each of the titanium loops gets a quarter, and the final quarter is looped back in to feed all the biochambers that are making the nutrients. Yes, it costs nutrients to make nutrients, and this is why the system can never stop running. As Chat put it, it's not so much a factory as an aquarium with existential risk. At this point, I think it's time to do some maths on the system, but don't worry, I'll be brief. How much nutrient does it need? Well, each fish costs 100 nutrients, but because it's being made in a biochamber with 150% productivity, there's a bit of a discount, so they actually only cost 66.6 nutrients each. Each fish turns into 17 bacteria, and then each bacteria turns into 8 spoilage. That's 136 spoilage per fish, which can then be made back into 13 and a bit nutrients, or about 20 with a productivity bonus. So, as expected, it's not a self-sustaining system. We need more than 40 additional nutrients per cycle, or even more considering that the nutrients power the machines as well. Mike is very much aware of this problem, which is why there's a coconut plantation running on this island as well. The coconut trees produce a number of things, and we'll start with the wood byproduct. That's being brought into these assemblers in the middle, where it's being thoroughly boiled with steam made from the excess heat from those heating towers I talked about earlier. That's producing wood pulp, which gives us another source of nutrients via these biochambers here. Great, that's another chunk. They're running pretty much flat out, so that means 15 per second each. That's a healthy amount. He's also using that steam to run a turbine to provide power to literally just this pump. Mike, we have diesel-powered pumps. What are you doing? I was expecting this to be for a roboport. What's that? Oh, there was originally an electric smeltery on this island to cook the titanium plates, but that got deprecated. The pump is essentially a legacy system now, and could be swapped out to remove all the electrical systems here. That would be nice, much cleaner. I also wondered where these towers were getting all their fuel from, since they're basically at full temperature, despite only being there for emergency disposal of excesses. Well, it turns out there's quite often an excess of coconuts, and that seems to be their main fuel source. Well, that's good, it means they won't cool down and stop the wood pulping, but if the wood processing did fail, then that would create a backlog of wood down this belt and... oh no, wait, that wouldn't actually get to the heating towers. This is a filter splitter. Never mind. Let's just hope the excess coconuts never stop. So, that's a nice healthy nutrient boost, but the big one is even further down. This is a very familiar looking system, but I don't mean that as a criticism. We're playing cooperatively, and just like I copied Tristan's port and was inspired by Mike's fish fermenting last time, he's copied my coconut processor. No point in reinventing the wheel. This is processing some of the coconut meat into extra nutrient, which fuels its biochambers, and then some of the excess is peeled off at the top for the titanium. It's also making coconut oil, which he's using to power all of the inserters and assemblers on this island. I'm in two minds about that. On the one hand, running it all off coconut oil makes sense because it's being produced from resources that are grown on this island, and self-sufficiency is an admirable goal, especially when the penalty for running out is so harsh. But on the other hand, turning so much of the coconut meat into oil for fuel reduces what's left for nutrients, the current limitation, and now that we have ethanol, we could ship that in instead. On the other hand, I did only just build the ethanol system, so it's quite understandable that he hasn't switched over yet, even if he plans to eventually. Maybe I should let him answer about what his plans are here. I believe it's not really being considered, but it is a possibility. The coconut husks are an unwanted byproduct over here, so Mike's just burning them up in more heating towers. They could be turned into activated carbon, but there's no need for that on this island, and I don't think it's worth the hassle of setting up processing, shipping, overflow and so on. It's an unwanted byproduct from a free resource, so I'm fully behind the incineration. Most problems can be solved with fire. I do note, however, that there's an excess of coconut seeds building up. These do need to be diverted off to also be solved with fire when they start to back up like this. With this coconut production, we've now answered the question of where the nutrients are coming from. This system is capable, apparently, of making a bit less than 200 titanium dust per minute, with the limiting factor clearly being the nutrient production. Since we're not actually using any titanium dust yet, I think that's going to be sufficient. I'm also told it should be enough once we start making science too, so even better. This has been a rather middle-out description of the titanium processing. I skipped over where the actual titanium sludge is coming from because it's less exciting than the processing, but we'll cover it quickly now. Mike started doing the processing on this island because it's a decent size and has 2 titanium sludge patches right next to it, which he's hooked up to oil rigs. These are supplying about 130 sludge per second between them, which is enough for about 6 of the dust makers, and that's not enough. So he's tapped another patch a bit further away and is shipping the sludge over to keep the system topped up. The other patch is currently producing about 220 sludge per second, so whilst it's not a huge quantity, it's more than doubling what was available before. If we need even more, there are more patches further afield. This would not be an insurmountable problem. On the other end of the production chain, the titanium dust is being sent out to a port, ready to be collected and taken away by ship to wherever it's needed. If you watched the last video where I talked about the system, you might remember that we were previously sending titanium plates to the port. However, Sophia realised that the dust is required for the science pack, and Mike noted that turning dust into plate on site is very straightforward and doesn't take up a lot of space, so we reckon it makes a lot more sense to ship it out as dust. Also, that's a lot of fish in that bay. I think he might be starting a fish farm in case the mechanical breeding doesn't go as well as he hoped. And there we go! I bet you didn't know that making titanium required quite so many fish. I've been trying something a bit different with the last couple of videos, which should make them a bit more structured, a bit less waffly. Please let me know what you think in the comments or on Discord. It's a bit more work to make them like this, but I do think the quality bump is worth it. I'll keep releasing them like this every Thursday and Friday, so please make sure you're subscribed so you don't miss out. We'll also be back to stream some more Planetary Pioneers on Monday at 7:30 PM UK time, and if you'd like to try your hand at the mod pack, you can grab the Planetary Pioneers mod from the Factorio mod portal and use the seed 11111 to get the same universe generation as us. Finally, I'll be streaming something else on my own on Wednesday at 8 PM, so it'd be great to see you there. Thanks for watching, and I'll see you next time. Bye bye.